so can you please, Jillian, help us read the instructions for examples 1 to 12? Yes, so can I have negative exponent in any of my answers? Nope. Okay, here we go. So you have the quantity of 5 times x to the 4th times 6 times x squared. You have some real numbers and some variables together. What I recommend is putting all of your real numbers together and all of your variables together. These are all multiplication. Then compute real numbers as always. 5 times 6 is 30. Well, what do we do? Are the bases the same on the variables? What do you do with the exponents? You add them. So if you can add it right away in your head, go ahead and write the answer. If you don't, write it out. So find the answer is just 30 times x to the 6. Box that up. Similarly to dividing. Again, this is just a review of Algebra 1. So we are going to break up the real numbers. All of this is already positive power, so we're just going to divide that out. Can I reduce 8 and 6? Yep, what will we get? 4 and 3. Then can I do anything with the y to the 9th and y to the 3rd? What do we get? Good. Would you agree? Because when you guys are dividing and the base is the same, we subtract. So technically, this is 4/3 y to the 6th. Or you can even write it like this. 4y to the 6th all over 3. Either one will be okay. Now, power to the power. What do? We multiply. The 2 right now has what power? Right now, before we distribute the power of -3, what power does the 2 have? 1. Okay, so be mindful. If you don't see a power, it's always a 1. So it's really technically 2, 1 times -3 times x to the 4 times -3 times y to the 2 times -3. Okay. Then this is 2 to the what power? -3. Then this is x to the what power? -12. Then this is y to the what power? But it says you can't have any negative exponent in the instruction. So how do I make all of this positive? Yeah, what do we do with all of these?
Turn it into a fraction of 1 over everything with the exponent.
So now I'm going to put it underneath. Would you guys agree with that? So the 1, so if I move it to the underneath, this is now 2 to the positive 3. X to the positive 12. Y to the positive 6. And then what's on the top? 0, 1. 1. But we have to simplify 2 to the 3rd. So what's 2 to the 3rd? 8. And everything else should be the same. All right. 5. What power does the x currently have before we distribute the 4? 1. So can I just write straight x to the 4th? Okay. So x to the 4th. Ella, y squared to the 4th power. What do we do with those? Good. So what would we get? Good. All over in the bottom. Kelsey, what do we get on the denominator? Z to the 4th. Anything negative? Can we reduce anything? Nope. So guess what? Box it. Whoops. Okay. I want you to take a moment and look at number 6. -19, x to the 7th, y to the 6th, all of it in quantity, and all of it's being raised to what? 0. So what should we do? Anything, any number, any variable that's raised to 0 power is always 1. Doesn't matter how ugly it looks. Okay. 7. We have 3 quantities here. You have some real numbers and some variables. What should we start out with? X is 0, yeah, that's a good idea. X is 0, just simply what? 1, you're right. What else should we do? Should we put all the real numbers together? Yes, that's always a good strategy for organization. So we're going to go -2 times what? 5. Good. Remember, x to the 0 is already 1. So do I need to worry about that? No. Or technically, can I really write the 1 right there too? Yeah. Now, next is your x variable. I have x to the 3rd. Any other x's I need to write next to it? X to the what? -1. And then our next variable would be the what? Y to the -4 times y to the 7. Okay. Okay, here we go. -2 times 5 times 1 would be what? -10. X to the 3rd times x to the -1. What do we do those two exponents? X squared, because we add them, right? Because 3 plus the -1. I'm going to write that step. If you don't need to, you can just go straight to x squared. Then y to the -4 times y to the 7th. We add the power. So final answer is -10 x squared y to the what? 3rd. Do I make that -10? Do I move it to the bottom? No, because is that a power? No, it's a real number. Okay. Okay, why don't you and your team try out 8? I'll give you a 1-minute head start. Try 8. Once you have an answer, can you please consult with one another, because I'm just going to call about 3 students to give me the answer. Did you get a chance to consult with your team? Awesome. So, Logan, what did you end up getting, hon? 400x to the what? Okay. Then Juliet, what did you get, hon? Okay. Do the 13? Okay. And then Kat, what did you get, hon?
400x to the 13.
All right. Looks like you guys all have matching answers, and you guys come from different groups. So let's see. Shh. All right. Heather, what do you think we need to do first? Okay. So -20 should get what power? Square. And then x to the 3rd should also get what power? Square. Does a 7 get a square? No, right? So that's something that we have to be super careful about. Would you guys agree? So negative number and you square it, should that always be positive or negative? Positive. So that's why your friend has 400. So 400. Power to the power, now I would have x to what? 6. And then x to the 7, drop it down. Bases are exactly the same. So you add, so you guys are good. Awesome. All right, go ahead and do 9. Get a head start. I'll give you 1 minute for 9. If you're done with 9, try 10, 11, 12, especially if you are done before the minute it's up. Okay. Once you're done with 9, compare your answers. If everyone in your team if you guys all have matching answers, then you know you're on the right page. Okay? Then move on to 10 if you will.
Final answer?
Okay. Are we done with number 9? Okay. So well, and if you're not done, just say I'm not done, and that's okay. Okay. Audrey S, do you have an answer for number 9, hun?
Yeah.
What do you have?
I got 1 over 2x to the 4th y.
2x to the 4th, y to the 11th. Okay. And then Ella, did you have an answer to number 9, hun? Okay. And then Tyler, do you have an answer to number 9? 1. Oh wait, hold on. I get erase. 1x to the 4th, y to the what? 11 all over 2. Okay. All right. So those obviously are different answers. Let's work it out. So the quantity on the numerator, they should all be distributed to what power? 3. So that's 2 to the what power? 3, right? And then you got x squared to what power? 3. Then you got y to the 5th to the 3rd. All of it has to be distributed. And the bottom, all of that should be distributed to power of what? 2. So x squared, and then y squared to the square. So far, so good? Okay. 2 to the 3rd is what? 8. So that's 8. X squared to the 3rd is x to the 6. Y 5th to the 3rd would be y to the 15. 4 squared would be what? 16. X to the 1 power to the square is x squared. Y squared to the square, y4. Can I box that up? No, let's reduce. 8 over 16 will give us a what? Whoa. 1/2. Yep, hold on. So 1 over 2. Would you guys agree? Remember, when you're dividing, you are subtracting the power, but be mindful of where it is more of. The top is more, then it stays on the top. If the bottom is more, then it stays in the bottom, right? So x to the 6 divided by x squared, when you subtract the power, you should have x to the 4th, but where do you keep it? On the top, okay? So that's really x to the 4th. Then y to the 15th divided by y to the 4th, again, you're subtracting, but where do you keep it? The top again. So this is y to the 11th. So this is your final answer. All right, just 3 more, then we are done for today. Now, can you guys see that on this one, all of the exponents are negative? So let's move it to make it positive first. X to the negative 5 on the numerator, how do I move it to make it positive? Okay, so now this is x to the 5th. Y to the negative 2nd, where do we move it? Denominator as well. Then this guy right here, how do we move it? Numerator. This dude right here, numerator. Okay, now let's simplify. X to the 3rd divided by x to the 5th. I know you are subtracting, but where do we put the x squared? On the bottom, because you agree that there are 2 more x's on the bottom. Okay, so that's x squared. Y to the 4th divided by y squared, we end up with y squared. But where do we put it? On the top. Can I do anything else from here? No, because x and y, they are different bases. We cannot subtract those powers. All right, next. Here we go. You have it to the negative 3 power. You do the same thing. You go 4 to the negative 3 power, then x to the negative 2 to the negative 3 power, y to the positive 3 to the negative 3 power. Well, let's make them all. How do we move so that way 4 to the negative 3 is now positive power? Okay, so this is now 4 to the positive 3. Would you guys all agree with that? X to the negative 2 to the raised to the negative 3 power, multiply the power. What do we get? 6. Do I need to move it anywhere? No, maintain it to the top. Y to the 3rd to the negative 3 is really technically y to the negative 9. Would you guys agree with that? But we want all positive answers, so where should we move that guy? To the bottom. So we do need to compute 4 to the 3rd. What is 4 to the 3rd? 64. Okay. All right. Ooh, there's a lot of stuff in there. Yes, Ella. Because 4 to the third. 4 times 4 times 4. Yeah, so 4 times 4 would be 16. 16 times 4. Last one. Do you guys want to make them all positive first and then distribute -1, or just distribute -1 power first? Okay, let's do that then. We are going to distribute the big power outside. So this is currently -1. Raise it to -1. This is now y squared. Raise it to -1. This is now z to the -3. Raise it to -1. And then all over. This is -2 at the bottom. Also raise it to -1. This is y to the 5th. Raise it to -1. This is regular z to the power +1 currently. It's raised it to -1. Some of them will turn itself into positive. And then obviously if it was positive before, it would turn itself to what? Negative. And let's see what happens. So on the numerator, x what? Just x, right? Y to the what? -2. Z to the what? 3rd. Regular 3. Yes, no, maybe? On the bottom, x to the +2. Y to the -5. Then we got z to the -1. Should we make all the negative positive before we reduce? Okay. So I'm going to say x here. Would you agree that y would now move to the bottom? Okay. And then this x stay. Would you guys agree with that so far? This y squared is now on the bottom, but this y to the -5 will go to the top. So that is all gone. Z to the 3rd, stay to the top. Yes, no, maybe? But this z to the -1 will do what? Move to the top. Final answer. We got x, 1x to the top, 2 x's on the bottom. Where is the extra x going to stay? On the bottom. So that's gone. Y to the 5th divided by y squared on the numerator. How many y's do we have left? 3. Y to the 3rd times, I'm sorry, not y. Z to the 3rd times z to the 1st power on the numerator. Z to the 4th. And that is it. Yes?
Why wouldn't you subtract the z to the -1 power on the bottom to the z to the top?
Technically, you can. Okay. That's a really good question. On the top, would you agree that you have z to the 3rd? Is that what you mean? Yeah. When you subtract and then the power is negative, it becomes z to the +4 anyway. You're right. That's a really good question. Okay, that's